This is section 9.1, adding and subtracting polynomials. So there's a lot of new vocabulary. So first we have a monomial, which is just a number, variable, or product of a number and one or more variables with whole number exponents. So the things that we were dealing with in the last section would all be monomials. So something like 4x squared would be a monomial. Or even just a constant, something like 12. Or negative 100 x, y, 6. Those are all monomials. The degree of a monomial is the sum of the exponents of the variables. So for example, 5x to the fourth y squared would have a degree of 6 because 4 plus 2 is 6. A polynomial is a monomial or the sum or difference of two or more monomials, and each of the monomials is called a term of the polynomial. So for example, 4x squared plus 2x plus 1 would be a polynomial, and each term individually, like 4x squared, would be a term of the polynomial. 2x would be a term, and 1 would be a term. Some common polynomials that we see a lot are binomials and trinomials. So a binomial is just a polynomial with exactly two terms, and a trinomial is a polynomial with only three terms. So the example I gave you up here would be a trinomial. It's a polynomial, but more specifically you can also call it a trinomial. So the degree of a polynomial is the highest degree of any of its terms. So for example, 4m cubed plus m squared minus 5m would have a degree of 3 because that's the highest degree of the polynomial. The example I gave you up here would have a degree of 2 because of the 4x squared. And then the last thing you need to know, the leading coefficient is the coefficient of the term with the highest degree. So for example, 4m cubed plus m squared minus 5m, the leading coefficient would be 4. So it's proper to write a polynomial from highest exponent to lowest, but if it happens to be written in the wrong order, really you should fix it, but the leading coefficient is still going to be the coefficient of whichever term has the highest degree of exponent. Alright, so just like in the last section, we want to simplify our polynomials and write them in simplest form. So for that to happen, there have to be no like terms present. So if there's anything that you can still combine, you have to do that. You need to simplify it before you try to figure out what the degree is. Like I said, it needs to be in order and everything needs to be combined. Otherwise, it might change your leading coefficient. And then it also, looking at the order, might change where you're looking to find the degree. And again, a polynomial should always be written in order of decreasing degree. So, for example, 4x to the 6th minus 3x to the 4th plus 5x cubed minus 1. That would be the correct way to write that, where you have the 6 first, the 3x to the 4th, and then the 5x cubed. The constant always goes last, because technically it has an x to the 0 power, which is just 1, and since 0 is the smallest, constant term always comes last. And then if you see a polynomial with more than one variable, you go decreasing order, but then you also go alphabetically. So for example, 2x squared plus 3xy squared plus y cubed. So even though y cubed is the biggest, it has to go last because we started with x first. Okay, so the first thing we're going to do in this section is add and subtract polynomials. The best way to do this is to either underline or draw shapes or use different colors to help you focus on like terms. So I want you to think of adding as just combining like terms. So for example, I have 4x squared that I'm going to want to combine with 3x squared. I have a 2x that I'm going to combine with this 1x. I have negative 6. Keep in mind the sign in front of a term has to go with it. I have negative 3. And then the only one that doesn't have a like term is the negative 2x cubed. So that's already simplified because it doesn't have anything else to combine with. But remember, I want to write it in order. So my x cubed term is actually going to come first, 2x cubed. And then 4x squared plus 3x squared. And then 2x and x, and negative 6 plus a negative 3. Okay, so when I get my final answer, I have negative 2x cubed plus 7x squared plus 2x plus 1x is going to be 3x. And then negative 6 and negative 3 is going to be, you can either write it as plus a negative 9 or just minus 9. And that would be our final answer. That's as simplified as we can get adding these two polynomials. Okay, and then the other thing we can do with polynomials for now is subtract them. It's going to be almost exactly the same as adding, except you need to distribute the negative. So because you're subtracting this whole polynomial, you have to do minus 5x squared minus 3x cubed and then minus a negative 2x is going to become plus 2x, and minus a positive 1, so minus 1. So now we can just think of this exactly like the other problem. Go ahead and group all of the like terms and then get your final answer. So now we can just think of it as adding since we went ahead and distributed the negative. And another way you can do it if you don't have colors is to use shapes. So for example, I could do, triangle 6x cubed and negative 3x cubed. Again, making sure that you know the negative, the minus, has to stay with it. I have a 2x squared and a negative 5x squared. I have a negative 4x and a positive 2x, and then a positive 3. Kind of running out of shapes. And a negative 1. So then again, I'm going to go in decreasing order. So negative 3x cubed plus 6x cubed is a positive 3x cubed. Remember, combining like terms, I want you to think of it as counting. So you have 6x cubes, and then you're taking away 3, so you're left with 3x cubed. And then we have negative 5x squared and positive 2x squared, which is a negative 3x squared. Positive 2x and negative 4x is minus 2x. And then positive 3 and negative 1 is just a positive 2. So our final answer, when you subtract those polynomials, would be 3x cubed minus 3x squared minus 2x plus 2. So again, combining like terms, I want you to think of it as like counting up how many you have of each term. So when we are subtracting this, we're left with 3x cubed terms and negative 3x squared terms and negative 2x's and positive 2. Alright, and then once again you're going to write it in decreasing order. So the cubed term came first, then the squared, then the x to the first power, and the constant always comes last. And that is it for this section.